Dear students, in this video we will discuss experiment number 3, that is figure of merit of galvanometer. So in this video we are not going to perform the experiments, just we are discussing theoretically and readings and calculations. So move on to the experiments. So aim of the experiment is determination of the resistance of a galvanometer by half deflection method and to find its figure of merit. Apparatus: pointer galvanometer, cell, resistance boxes. Actually here variable resistance boxes are there and two keys. So principle of the experiment: deflection in a galvanometer is directly proportional to the current through the galvanometer, that is I equal to K into theta, where K means what? K is called figure of merit of the galvanometer. So this is the principle and formula. Figure of merit of galvanometer K equal to E divided by R plus G into theta, where E means EMF of the cell and R equal to resistance in series with the galvanometer. G means galvanometer resistance and theta equal to deflection in the galvanometer. So this is about formula. So next move on to the diagram. Here in diagram, so EMF is there, E, and EMF of this is a cell and positive of cell is connected to the one end of galvanometer and another end of the galvanometer is connected to the K1 and another end of the K1 is connected to the variable resistance, that is capital R. So again here in galvanometer, one end of the galvanometer is connected to the one more resistance boxes, that is small resistance, and capital R means here high resistance and small r s means it is small resistance or shunt resistance, and another end is connected to the K2 and K2 is again connected to the G, or we can connect in other ways also. So here diagram is there. Move on to the observation. EMF of the battery is E equal to 2 volts. So tabular column is there. So these are the readings. Trial numbers are there. 1, 2, 3. 3 trials are there. Resistance R in ohm. Deflection theta in divisions. And S for theta by 2 in ohm. And G equal to R into S divided by R minus S, and K equal to E divided by R plus G into theta in ampere per divisions. So here first reading is 4200 and deflections are 30 and S half theta by 2 is 100 and G is calculated, it is 102.43, and finally figure of merit is calculated 0.0000154. Similarly, so for resistance of 4500, 28, 100, 102.27, 0.0000155, and next 4900, 26 divisions, 100, 102.08 and 0.0000153. So these are the three readings are there, and average of G is calculated and average of K is also calculated, and average is calculated here. So G1 RS divided by R minus S, and this answer, corresponding answer. G2 is also R into S, R minus S. So that values are there in table, and finally we are getting that result. And G3, so G1, G2, G3 is calculated. Average G means 102.439 plus 102.177 plus 102.040 divided by 3. So adding all these 3 and dividing 3 will get 102.213 ohm. So similarly K1 is calculated, K2 is calculated, and K3 is calculated, and average of K is also calculated, means by adding K1 plus K2 plus K3 divided by 3. So finally we are getting 0.000015 ampere per division. So this is the experiment. So finally, what is the result of the experiment is the resistance of the galvanometer is 102.213 ohm, and figure of merit of pointer galvanometer is 0.000015 ampere per divisions. So this is all about the figure of merit. Thank you for watching.